Another way we can find a Taylor series is by transforming functions into a geometric series. So if you look, 1 over 1 minus x, it's very similar to what we've used before. If you think about it, that's really the same thing as a over 1 minus r. And we know a over 1 minus r is the sum of the series a times r to the n. So 1 over 1 minus x is just the same thing as a over 1 minus r. We're just saying that our a is equal to 1, and we're just trading our variable r for x is the only difference. So let's look at how we would write these three as a geometric series. Okay, so remember, what's on top is your a, and what's being subtracted goes in for r. So this one would simply be 1 times x to the n. So we know that series, and you can expand it and write out the terms if you want. It'd be, let's see, 1 plus x squared plus x cubed, and so on. You don't have to do that, just trying to show you that it's still a series. But you can write it in series notation by simply following this pattern of a over 1 minus r. So again, if you look at this example, 3 over 1 minus 2x, whatever's on top is our a, so that would be 3. Whatever's being subtracted is our r, so we'll have 2x in parentheses raised to the n. And then finally this one down here, 1 over 1 minus x plus 1. The 1 up top is our a, and whatever's being subtracted, in this case x plus 1, serves as our r. Just to answer your question, no, if a is 1, you don't have to write it right here. It's fine if you don't want to write this 1. Just trying to be very explicit about where these things are coming from. Okay, now the problem comes that things aren't always written exactly in the form of a over 1 minus r. We may sometimes have to manipulate them and rewrite them to get them in that form, because we can't change it from this step to this step unless we're already in the form a over 1 minus r. So here's what I mean. And also just sometimes the center is not where we want it to be. So this one, they want the center to be at negative 1. Okay. So watch carefully how we can change this. Remember that our goal is to get to be in the form a over 1 minus r, and we also want to be centered at negative 1. So let me say something about that. Your center is going to work when, if you plug it in right here, this piece becomes 0. So for example, what we have right now is being centered at 0 because the r is going to turn to 0 when we plug in 0. If you look back here, this one would be centered at 0, this one would be centered at 0, this one would be centered at negative 1. In other words, when you're looking at your r's, what would you plug in to make them 0? So the first two obviously are just 0. The last one would be centered at negative 1. So what can you plug into your r to make it 0? That's the question. Alright, so we need to be centered at negative 1. Well, obviously then, we need it to look like this. Because now if I plug in negative 1 for x, I get negative 1 plus 1, which is 0. So that part's right. But the problem is I've changed my equation. If you think about what these signs are actually doing, what I really have is minus x minus 1. So I've now subtracted 1 from the bottom of the fraction. And I can't just arbitrarily do that. I can't just say, oh, well, I'm going to subtract 1. You've changed the function. But you can balance that by adding 1 to the other part. So if I put a 2 out front here, this is now identical to what I started with. So let me show you why. So if you start here, and then you distribute the negative through, and come down to this step, 2 minus 1 just gives you 1, and you are right back where you started. So by both subtracting 1 and adding 1, we already had a 1 up here, now we're adding 1 more to it. By subtracting 1 and adding 1, you haven't effectively changed your function. It's still the same thing. You plug anything into this, you're still going to get the same value back. You've just rewritten it so that now you're centered at negative 1. So one thing you have to do, and we're going to write out the steps for this very explicitly in the next slide, is whatever you do right here, you've got to do to this side over here. So since I had to add 1 to this x, I have to add 1 to this 1. So that brings us to this step right here. Unfortunately, we can't leave things like that either, because if you look, the form is very specifically a over 1 minus r. I can't allow that 2 there. It's got to be a 1. So the question is, how do I change that 2 to a 1 without screwing up what I've done to center it at negative 1? Well, the answer is simply to divide everything by 2. So I divide the top by 2 and I get 1/2. Divide 2 by 2 and I get 1. And then divide x plus 1 by 2, and you just leave it written like that. Now I am in the form a over 1 minus r. My a is 1/2, and my r is x plus 1 over 2. So now I can write this as a geometric series, and it will be a times r to the n. Now that may have seemed pretty convoluted, I don't know, but there's 4 steps to these, and if you can remember these 4 steps, you can do any one of them. So the steps are very important, and they're very important that you do them in order. I don't know if you've ever solved a Rubik's Cube, but part of the whole concept there is once you solve one layer of the cube, you've got to figure out how you can solve the second layer without messing up what you did in the first layer. So that's similar here. We do things in this order so that once we've accomplished step 1, sorry, I forgot to parentheses there. Once we accomplish step 1, we've got to make sure the rest of our steps don't mess up what we've done in that previous step. So the order of these steps is extremely important. So the first step is to make sure in your denominator you go number, then variable. So as you can see there, I'm saying you write it 2 plus x, not x plus 2. Because the formula is a over 1 minus r. So the 1 comes first, the r comes second. So you always want to make sure that in the denominator it's number, then variable. Okay, the second thing is you need to make it a minus sign. It's 1 minus r, not 1 plus r. So if you have a plus, you can see you can change it to just be minus a negative, and that will fix it to where you have a minus sign like you need it. The third step is to fix the center, and you saw me do that earlier in this step. And the simple answer is that whatever you do to the x, you'll also have to do to the 1 over here. We added 1 here, so we had to add 1 here. So that will balance it out for you. So fixing the center. And then the fourth step is to make it a 1. You also saw me do that step. We had a 2 where the 1 should be, so we had to divide everything by 2. So whatever is there, you need to divide by whatever it will take to make it 1. So let's follow these steps with this problem right here. So first step is to change it so that the denominator is a number, then a variable. So that's not hard. I just change x plus 2 to 2 plus x, because I want the number to come first and the variable to come second. Okay, my second step is to make it a minus sign. So again, that's not difficult. I just change plus to minus a negative x. My third step is to make sure that my center is correct. Well, remember, just this part right here is your r, just that part. And if your goal is that when you plug in your center, the result is 0. Well, if we plug 0 into negative x, we get 0, so that's perfect. Our center is fine, we don't have to do any adjustments there. But our third step is that we have to make this right here into a 1, because it has to be a over 1 minus r. So to accomplish that, we need to divide every piece by 2. So 4 divided by 2 is 2, 2 divided by 2 is 1, and then it's negative x over 2 to give you that result. Now this can be written as a geometric series. We plug in a, we plug in r, and we raise it to the n. And geometric series are going to start at 0 and go to infinity. Alright, so notice how we followed those 4 steps in a very specific order. You always want to go in that specific order. Okay, next, find a power series for f of x equals 1 over x, centered at c equals 1. Alright, so our first step is to make sure we have a number, then a variable. Well, you might be thinking, well, wait a minute, I don't have a number at all in the denominator. Well, sure you do. We just never bother to write it, because it's not very helpful, but except, in this case, it would be very helpful, because we need to have a number, then a variable. So just write 0. You can always add 0. That doesn't change anything. Now we have our first step accomplished. We have a number, then a variable. Okay? The next step is to make sure it's a minus sign. So I do 0 minus negative x. My next step is to make sure I get the center correct. Now this is typically the part that is hardest for most people, so I want you to listen very carefully to my thinking here, my thought process. Right now, if I plug 1 in for x, I get negative 1. I want to get 0. So to fix that, I need to add 1, because if I was getting negative 1, that means I need to add 1 to get to 0. So I'll do negative x plus 1. So now if we plug in 1 in for x, we get negative 1 plus 1, which is 0. That's perfect. But whatever we do to the x, we also have to do to this number over here, and that's going to give us a 1. If you were to simplify the bottom, you would just get x right back. You notice the two negatives would cancel out, making it positive x, and you'd have 1 minus 1, which is 0. So our function is still equivalent to what we started with. It's just written in a form we can use the geometric power series with. So now, we've fixed the center. It's centered at 1. And the last step is to make sure we have a 1 right here, which we do. So we're finished, and we can write it as a geometric power series. And we do a times r to the n. Next example. Change 4 over 3x minus 2 to be centered at 3. So we want to put this as a geometric series. Alright, first step, number then variable. So I rewrite the bottom to be negative 2 plus 3x. Don't forget to keep your signs the way they are. That's a positive 3x and a negative 2, so even if you write in the opposite order, it's still got to be a negative 2 and a positive 3x. Next step, we need to change it to a minus, so we make it minus negative 3x. Okay, our next step, the third step, is to fix the center. Alright, again, listen carefully to my thought process. If I plug 3 in right now for x, I get negative 9. Negative 3 times positive 3 is negative 9. So to center that so it gives us a 0, I'm going to need to add 9. But whatever I do to these parentheses, I have to do to this number over here. So negative 2 plus 9 is 7. Again, if you were to simplify that denominator, it would give you exactly the same thing you started with. The two negatives would make a positive 3x. 7 minus 9 is negative 2. So we've completed the first 3 steps. The last step is we need to change this number into a 1. To accomplish that, we have to divide every piece in the fraction by 7. So 4 over 7 on top, 1 right here, and then negative 3x plus 9 over 7, oops, sorry, getting ahead of myself, on the bottom. So now it's in the form we need. It's a over 1 minus r. So I can write it as a series from 0 to infinity of a times r to the n. Oh, sorry, that was the last example. So hopefully that helped you. And if you will just remember these 4 steps, in fact, I think I'll just leave them up last. If you'll just remember these 4 steps and follow them very carefully, you should have no trouble at all.